Today, we're using this 3D physics simulation to visualize the mechanical advantage happening inside the drivetrain. We'll look at the extremes, the climbing gear versus the sprinting gear. Have you ever wondered exactly what happens when you shift gears on a bicycle? It's a battle between torque and speed. Think of your legs as the engine of a car. Just like a car engine, your legs have a limited RPM range where they produce power efficiently. To stay in that range while the terrain changes, we need a transmission. Let's start in Gear 1. This is your low gear. Look closely at the chain position. It is wrapped around the largest cog on the rear cassette. Count the teeth visually. This rear cog is almost as big as the front chain ring. Because this cog is physically larger, it acts like a longer lever arm coming off the hub. This gives the rider a massive mechanical advantage, essentially multiplying the input force before it hits the tire. See those large red arrows on the wheel? That represents torque. Mathematically, torque is just force times distance. Since the chain is pulling at a greater distance from the axle, that force arrow gets bigger. In this gear, the rider's legs are spinning fast, high cadence, but the bike is moving relatively slowly. It is exactly like using a long crowbar to lift a heavy rock. You have to move your arms a long distance to lift the rock an inch, but the rock feels light. We are trading speed for raw pushing power. This is why you use this gear to climb steep hills. You need maximum torque to fight gravity. Now, let's shift up. As we move the chain to smaller and smaller cogs, observe what happens. Notice how the chain has to physically derail and jump to the next ring. As it moves closer to the center axle, the lever arm gets shorter. We are now in Gear 6, the sprinting gear. The chain is on the smallest cog. This is roughly an 11-tooth cog compared to the 42 teeth on the front pedal. That is almost a 4-to-1 ratio. The mechanical advantage decreases. The resistance on the rider's legs increases. A professional cyclist is constantly hunting for the perfect balance here. They don't want to spin too fast and waste energy, but they don't want to grind too slow and hurt their knees. You can see the pedal strokes slowing down because it's becoming harder to push. But look at the ground moving beneath us. The speed is picking up. The chain is on the smallest cog. This is roughly an 11-tooth cog compared to the 42 teeth on the front pedal. That is almost a 4-to-1 ratio. Look at the force arrows now. They are small and blue. We have very little torque here. If you tried to start from a dead stop in this gear, you would likely stall out or have to stand up and crush the pedals. It's like trying to start a manual transmission car in 5th gear. However, for every single rotation of the pedals, the rear wheel spins 4 times. This multiplies our speed massively for flat sprints. To summarize, large rear cog means high torque, low speed, perfect for hills. Small rear cog means low torque, high speed, perfect for flats. Next time you ride, visualize these red and blue arrows. Don't just mash the pedals harder, shift smart to keep your torque manageable. Gearing is simply managing that trade-off to keep your legs moving at a comfortable pace, no matter the terrain. Thanks for watching.